Hello everyone, welcome back. Today we're going to be solving quadratic equations using the quadratic formula, but we're also going to consider complex numbers whilst we're doing so. And that's really what distinguishes what we're going to be doing today versus what you did a couple years back in Algebra 1, is that in Algebra 1, the second that we get a negative sign in our square root, we say that there are no solutions, right? Which is, or no real solutions, I should say, which is true. There are no real solutions. If we have a negative in the square root, there are only complex solutions. However, in these examples, I'm going to go further and actually go into what those complex solutions are and what they look like. So the main thing to recall here for stuff like this is that the square root of -1 is equal to I. And so anytime we have a negative in our square root, we will have an I, the imaginary part in some part of the solution. Okay, so in order to use the quadratic formula on this, first I need to get this into the proper format, which is ax squared plus bx plus c equals 0. So everything needs to be on one side, either left or right, doesn't matter. And then the 0 needs to be on the opposite side. So I'm going to add 4x to both sides and rewrite this equation as x squared plus 4x plus 18 equals 0. Because what's very tempting to do when I see this is to write that a is 1, that b is -4, and that c is 18. But when we put everything on the same side, we can see that it's actually +4. Now, let's say we'd put everything on the other side. Well, then we would have gotten all three of them negative. So either all of them are negative if we put them on the right, or all of them are positive if we put them on the left. And since positive numbers are generally a little easier to work with, I'm going to go with that. Always take the path of least resistance. Okay, so now let's plug this into the quadratic formula. And just a reminder, the quadratic formula is x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. So therefore, x equals -4 plus or minus the square root of 4 squared minus 4 times 1 times 18 all over 2 times 1. And that is equal to, well, let's see, -4 plus or minus the square root of, 16 minus 4 times 18. So 16 minus 72 all over 2. So right now we can probably already tell that there's going to be a negative in our square root sign, and we're going to end up with no real solutions, but we will end up with two complex solutions in this case. Okay, so then we're going to have -4 plus or minus the square root of -56 over 2. Now, in order to simplify what's in the square root as much as possible, I need to figure out, are there any factors of 56 that are perfect squares? And one that I can think of right away is 4, right? Sometimes if something that's divisible by 4 also works with 16, though 56 is not one of those values. 56 doesn't work with 16. And so I'm just going to do a little bit more to simplify this a bit further. So let's do that. Over here, I'm going to have -4 over 2 is -2, plus or minus the square root of 56 over 2. The square root of -56, though, keep in mind, is the same as root -1 times root 4 times, let's see, because 56 is the same as 4 times 14, so we'll do that. And the reason I'm separating it this way is because, first off, we definitely need to separate the root -1 in order to switch that to I from up here, so that's the first thing. And then also, as we know, in order to simplify a square root as best we can, we need to find any perfect squares that are factors, right? And in this case, the largest factor that is a perfect square here is 4. Right? As we can tell with 14, the only factors it has are 2 and 7, and those aren't, other than 1 and 14 itself, and 2 and 7 are not perfect squares. Okay, and then last step, let's just finish simplifying this. We're going to end up with plus or minus, -2 plus or minus 2, right? The 4 becomes a 2. The root -1 becomes I, and then we have root 14 over 2. And then, of course, we can just cancel these out, and we end up in the very end with -2 plus or minus the square root of 14 times I, like that. And there we go. All right, let's do one more example here. Example B, or actually two more examples, sorry. So for this one here, first thing I need to do is get everything on the same side. So x squared plus 4x minus 18 is equal to 0. Then I'm going to state my a, b, and c. A is equal to 1, b is equal to 4, and c is equal to negative 18. Then I'm just for reference, I'm going to write the quadratic formula here as well, like that. And then I'm going to sub my a, b, and c into the quadratic formula. So x is equal to negative 4 plus or minus the square root of 4 squared minus 4 times 1 times negative 18 all over 2 times 1. And that's going to be equal to negative 4 plus or minus the square root of, let's see, it's going to be 16 plus 4 times 18 this time. So that's going to be 16 plus 72 in there. So we can already tell that it's just actually going to be real solutions this time. And I should note it won't always be complex solutions, but it's good to know how to write the complex solutions because sometimes there will be complex solutions. So yeah, here we have negative 4 plus or minus the square root of 88 over 2. So that's going to be equal to negative 4 over 2, which is negative 2, plus or minus the square root of 88 over 2. Now, root 88 can be simplified a bit more. Keep in mind that 4 is indeed a factor. So this is going to be negative 2 plus or minus root 4, root 22 over 2. And root 4 is just, and 2 are just going to end up canceling. So we end up with negative 2 plus or minus the square root of 22. And those are our two solutions, right? The first one is negative 2 plus root 22. The second one is negative 2 minus root 22. And so in this case, we actually ended up with two real solutions. All right, let's do one last one here. So same thing as before, I need everything on one side. So I'm going to rewrite this as x squared plus 8x plus 41 is equal to 0. So in this case, a is equal to 1, b is equal to 8, and c is equal to 41. And as always, for reference, I'm just going to write down the quadratic formula here, like that. Okay. And then we're going to sub in our values for that quadratic formula. So x is equal to negative 8 plus or minus the square root of 8 squared minus 4 times 1 times 41 all over 2 times 1, which is equal to negative 8 plus or minus the square root of 64 minus 164 over 2. So then we're going to have negative 8 plus or minus the square root of negative 100 over 2. And then we're going to have negative 8 plus or minus root negative 1 times root 100, right? Because we're going to basically be separating this, the root negative 100 into root negative 1 times root 100, as those are both things we know how to simplify a bit better, right? Because as we know, I is equal to the square root of negative 1, and then the square root of 100 is just 10. So then we're going to have negative 8 plus or minus 10i over 2, and that's just going to be negative 4 plus or minus 5i, because essentially we're just going to divide negative 8 by 2 to get negative 4, and 10 plus or minus 10i divided by 2 is just plus or minus 5i. And so there we go. As always, feel free to leave any questions you might have about any of that in the comments below, and we'll see you for the next one.